Okay, we just have two quick examples today. For the first example, you can see that we really cannot choose this for the u, and we cannot choose this for the u. So a lot of people get stuck here. This example is actually a long division example. Whenever the degree on top is higher than the degree on the bottom, you can do long division. So it's just going to be the top divided by the bottom. So the top goes inside here, and the bottom goes on the outside. The way we're going to do this is we're going to look at the highest degrees, and we're going to say, what do I multiply by x to get x to the third? And the answer is going to be x squared. So we're going to write that down right here, x squared. And we're going to multiply all this stuff by x squared. That's going to give me x to the third minus 4x squared. Then we're going to do the top minus the bottom. Another way of doing it is to multiply everything by -1 and then add up all the pieces. So this is going to give me 0. This is going to give me x squared. And this is going to give me a 2. Okay, then we repeat that. Again, we're just looking at the highest degree. So we have x squared and we have an x. So what do we multiply by x to give us x squared? The answer is going to be x. So we're going to multiply everything here by x. That's going to give me x squared minus 4x. Now we want everything lined up. We have the x squareds here, but now we have a number 2 and an x. That's not good. So I'm going to move this plus 2 over a little bit. Again, it's going to be the top minus the bottom. Or you could multiply everything in the bottom by -1 and then add up all the pieces. This will be 0x squared. This will be 4x and then plus 2. Okay, last one. What do I multiply by x to get 4x? And the answer will be 4. So I'm going to multiply everything by 4. That's going to give me 4x minus 16. Again, we want to do top minus the bottom, or just multiply everything in the bottom by -1 and add up all the pieces. You're going to get 18. And there's nothing you can multiply x by to get 18, so 18 is going to be the remainder. And the way you deal with the remainder is you're going to put it over the x minus 4. So the integral of this fraction is equal to the integral of x squared plus x plus 4. And because our remainder was 18, I want to write that as 18 over x minus 4. Okay, you'll probably notice that I wrote it as two separate integrals. And that's because this is going to be a really easy integral. This one's going to be a little bit more tricky. You got to be more careful with that one. The first one doesn't even need a u substitution. It's just x to the third over 3 plus x squared over 2 plus 4x, and we can put our plus c. This one's a little bit more tricky. We're going to have to do a u substitution. So we'll let our u equal x minus 4, and then du dx is just going to be a 1. And you can multiply both sides of this equation by dx, and you'll see that du is just equal to dx. So we can trade our dx for du. And this is an easy integral. It's just going to be ln of the absolute value of u. Don't forget the 18 in front of it. And you notice I did not bring this constant down because a constant plus a constant is just going to be another constant. So you only need to put 1 plus c. We're almost done. Don't forget to trade the u for x minus 4. And then we're done. And that's it. That's our final answer. Let's put a box around it. And now we're done. All right, I'm calling this example the double substitution. So we're going to substitute once for the u, and then we're going to be left with x to the 6, and we're going to have to substitute again. So let's have a look at that. The first thing I want to do is choose my u. So my u is going to be x to the 6 plus 2. And if you do the derivative, you're going to get that du dx is equal to 6x to the 5. So let's trade our u for x to the 6 plus 2. And I'm going to need an x to the 5. I have an x to the 11. So you can break it up into two pieces. X to the 11 is x to the 6 times x to the 5. So I'm almost there. I have x to the 5. I need 6 x to the 5. So I can put a 6 as long as I put a 1 over 6. And I'm almost done. This is a du dx, and this is a dx. So my dx's are going to cancel, and I'm just going to be left with a du. So I'm just left with a du here. So these two things turn into just a du. Now normally when we get to this step, we're done. We can do the integral, but we have a problem. We're still left with an x to the 6. What do we do? So this is a tricky example. Again, it's called a double substitution. If you work with this equation here, you can solve it for x to the 6. So we're going to try to do that. If you just subtract 2 from both sides, you're left with x to the 6 is equal to u minus 2. So we can trade our x to the 6 for a u minus 2. There's still going to be one more step. We want to distribute the u to the 9 on both pieces. So that's going to give us a u to the 10 minus 2u to the 9. Now we finally reach a spot where we can actually do the integral. Our integral is going to be u to the 11 over 11 minus 2, and then u to the 10 over 10. Don't forget your plus c, and don't forget your 1/6. Now a lot of people will distribute the 1/6 on both pieces. That's fine if you want to do that. And there's still a little bit of simplifying I can do. Here we have 6 times 11, that's 66. This right here is going to be negative 1/3. And of course we can do the 3 times the 10 and we get a 30 on the bottom. And now all we have to do is plug in for the u. Remember the u was x to the 6 plus 2. And that's it. That's our final answer. Let's put a box around it. And now we're done.